But 2,6 and 2,7 deals with rational functions. We're going to graph them, and asymptotes. Guys, a rational function is just a grown-up way of saying fraction. All right, a rational function is a fraction. Okay, so like I just said, guys, rational functions, it's a grown-up way of saying a fraction. All right, so we're going to discuss rationals. All that means is fraction. Rational functions are quotients of polynomial functions. So you're going to have a polynomial in the numerator, polynomial in the denominator, and you're going to divide. Okay, it's a division problem is essentially what it is. The only thing we're going to talk about today is domain. All right, domain. That's what values can you use for x. So if I gave you this polynomial right here, if I said f of x equals negative 17x to the fourth plus 7x squared minus 19. All right, you guys have seen these a lot. We've been talking a lot about stuff like this. And you were finding the zeros and all that good stuff. If I said to you guys, what's the domain for this polynomial? What I mean is, what can I plug in for x and get out an answer for y? Could I plug in any positive number in the whole world? Yeah. Could I plug in any negative number in the whole world? Yes. Could I plug in 0? Yes, I still get an answer. So your domain for most polynomial functions is negative infinity to positive infinity. Your domain for, as long as, I shouldn't say most, for a polynomial function, your domain is negative infinity, positive infinity. When you put a polynomial on top of a polynomial, when you try and divide them, when you have a rational function, then you're going to get a couple domain restrictions. We're going to talk about that right now. Here's the 3 things you've got to remember. We know this already. You're going to like put it into actual form here, but you guys know this already inherently. Okay, if I said to you, your first issue, you have to look to see, we'll call this issue number 1. It says domain of a function is all real numbers except for, here's the 3 times it's the exception. There's a variable in the denominator. Guys, we already know why. Why can't you have a variable in the denominator? What number can you not have in the denominator? 0. Then your function becomes undefined. So if you have a variable in your denominator, say you have 13x over 7x plus 3. All right, this is a rational function. Why is this a rational? Because you have a polynomial in the numerator, polynomial in the denominator. It's a fraction. But you just can't say, oh, you can plug in any number in the world. The reason why is there is a variable in the denominator. So what does it say to do if there's a variable in the denominator? How do you find out what the domain is? You set the denominator not equal to 0. So you guys would say, okay, 7x plus 3 cannot be 0. And you solve that. So this becomes 7x cannot be negative 3. Divide both sides by 7. So you tell me that x cannot be negative 3 over 7. What happens when x, the value of x is negative 3 over 7? You plug it in, your denominator becomes what? Undefined, or 0. So you can use any number in the entire world except for negative 3/7. How would I write that in interval notation? What would your domain be? Negative infinity to negative 3/7. Then negative 3/7 to infinity. Why did we use a parenthesis? I agree. Because it's not included. So you can use any number in the entire world except for negative 3/7. And the reason why is when you use negative 3/7, your denominator becomes 0, which then your fraction becomes undefined. All right, so second problem or issue is if there's a variable underneath a square root. Well, let's think about this for a second. Why is that a problem? If we're talking about real numbers and real solutions and stuff, why is it a problem if there's a variable underneath the square root? Can't take negative square roots and get a real answer. Good. So, see, you guys already know this. So, let's just say I'm looking at a polynomial and it looks like this. Whatever. X minus 8. All right, so you're going through and it says, what is the domain? And you're like, well, there's not a variable in the denominator, so we're good. But there happens to be a variable underneath a square root. So how do we solve this? We don't set it equal to 0. What do? Greater than or equal to. Why is this greater than or equal to and not just equal to 0?
Because it has to be positive or 0.
Got to be positive or anything bigger. It's not just one exact value that can't be under there. It just has to make sure that the value underneath the radical is 0 or bigger. So in a case where you have a radical, you just set it greater than or equal to 0. And then we solve. So we're going to square both sides, correct? So x minus 8 greater than or equal to 0. Then do what? Add 8 to both sides. So you get x is greater than or equal to 8. So you're telling me that you have to use 8 or bigger. How do we say that? What's your domain? Bracket 8 to infinity. Now look, try this. Plug in 8. What's 8 minus 8? 0. It's the square root of 0. 0. You're good. Okay, try something smaller than 8. 7. What's 7 minus 8? -1. Is that going to give us a real answer? No. Okay, good. All right, and then the third issue is kind of like a combo of those two. Number 3. You're looking at this and you're saying, is there a variable under a square root also in a denominator? So it looks something like this. Whatever, just made something up. So your 3 rules. Number 1, you have to see, is there a variable in the denominator?
Yes.
Okay. Number 2 is there a square root? Or is there a variable underneath the square root? Yes. So this is a combination of 1 and 2. So think about this for a second. If you have a radical, you have a square root, your number has to be bigger than 0, right? In order to be positive, to be real. But since we're in the denominator, can it equal 0? No. So in this case, when you have this double whammy where it's a variable underneath the square root and it's in the denominator, it's not greater than or equal to, it has to be greater than 0. And the reason why is because where the radical is located. Since the radical is not in a numerator, it's underneath, it's in a denominator, then this value cannot be 0, it has to be bigger than 0. So we would square both sides. You get x plus 3 greater than 0. So x has to be greater than what? -3. How would you write that? -3 to infinity. What goes on the -3? Parenthesis. Good. It does not include it. That's the difference there, guys. If it's just a radical in the numerator, greater than or equal to, that means it includes that number. If it's in a denominator, it does not include. So those are your 3 domain restrictions that you have to be aware of every single time you're asked for the domain of a rational function. And I'll show you your little cheat sheet here at the end. I'm not going to talk much longer. If you go to the example here, find the domain of a rational function. The computation that you guys are going to have to do is very minimal. It's understanding what part of the fraction are rational to look at, whether I'm looking at the numerator, the denominator, what it's telling me. But if you guys are asked to find the domain, where do we look? In the numerator or the denominator? The denominator. Good. You guys need to be practicing this. This is another reason I take a long time on this, because you guys, there's a lot of information. So the denominator.
Doesn't cancel out because you can do x plus 4, x minus 4?
We're not, when we get to the end, when you're talking about doing the whole thing in wholes and stuff like that, yeah. But if you're asking for just the domain, no, it's not going to cancel out. You have to figure out, that's a good question. You have to figure out the domain before you start canceling out. So let's talk about this. What is the issue? Is there a variable in the denominator? Is it underneath the square root, or is it a combination of the two? Variable in the denominator. So you guys would say, okay, x minus 4 cannot be 0. Since the variable is in the denominator, it's not underneath the square root or anything, you're just setting it not equal to 0. So we're going to solve both sides. So x cannot be what number? 4. It could be any other number in the world. Just cannot be 4. And what we'll see, Nick, here in a couple days is instead of an asymptote being at 4, it'll actually be a hole in the graph. So how would you tell me that I can use any number in the entire world except for 4?
-infinity to 4.
-infinity to 4. parenthesis, 4 to infinity. Very good. It does not include 4. Because if you did, what would happen? 4 minus 4 is 0, then your denominator becomes undefined. All right, does that make sense? All right, look at the next one. All right, find the domain. Oh, I see the word domain, so I think denominator. That's where I'm looking. I look at my denominator. Is this a variable in a denominator? Is this underneath a radical, or is it a combination of the both? It's just a variable in the denominator. So we say, okay, x squared minus 36 cannot be what number? 0. So when I go to solve this, guys, just pay attention to what you're doing. What happens when I have x squared on one side and 36 on the other? You take the square root, great. When you take the square root, guys, what goes in front of your answer? Plus or minus. So this is not, I just can't have 6. I can't have positive 6 or negative 6. Last period I had a really tough time for some of them for seeing this. So let's think about it. If I was going to put this on a number line, do you guys agree with me? 0 would be here in the middle, so negative 6 would be on the left, positive 6 is on the right. If you were going to graph on a number line, is negative 6 and positive 6, is that included in your domain or not? So if I was going to put a dot here, it would be an open circle. Do you guys agree with that?
Yes.
Because it's not included. So you can use everything on the left-hand side over here. You can use everything on the right-hand side over here. And you can use everything in the middle. You just can't use those two numbers, negative 6 and positive 6. So what would your domain look like for this? Negative infinity to negative 6. Agreed? Okay, then what? Uh-huh. Very good. Negative 6 to 6. Sometimes we forget that middle section. And then what? 6 to infinity. Good. This is telling me you can use every single number on the left-hand side of negative 6, in between negative 6 and positive 6, and then everything to the right of 6. You just can't use the number negative 6 itself or positive 6. Because what would happen when you square 6 or negative 6, you get 36. 36 minus 36 is 0. Then your function becomes undefined. All right, so pay attention. Those 3 rules, ask yourself every time. Now, scroll all the way down to the last slide. I'm fully aware that this looks like Valentina or Reagan wrote it. Just go with it. I use this every year. This is your asymptote, rational 2627, however you want to call it, cheat sheet. You will not be able to use this on a test or a quiz. But every single time you do anything for WebAssign, for your practice that we're going to do, for your test review, you should screenshot this and put it next to every single question. Because you're going to be asked, you're going to be given a rational function. And it's going to say, find all of these things and graph it. This is on the last slide of your notes, guys. So if you look at domain, every time you are asked the question, how do you find the domain? Where do you look? Numerator or denominator? Denominator, okay? If you're asked for the vertical asymptotes, which we're going to talk about tomorrow, where do you look? Denominator. Look, these two things go hand in hand. Whenever you find the domain, you're also finding vertical asymptotes. What does vertical mean? Up and down or left and right? Up and down. So a vertical asymptote is going to be a boundary line. It's an imaginary one. You can't see it. But that your graph is going to get really close to, but not touch. So then we're going to talk about horizontal asymptotes. And I'll explain all of this tomorrow. But you're going to have to look and compare the degrees of the numerator and the denominator. If I say to you guys, okay, for this function, find the slant asymptote. You guys are like, what? First of all, what does slant mean? If something is slanted, show me with your arm. Okay, it's kind of like that. Good. But how do you find the slant asymptote? What does it say to do? Use long division, okay? If you're asked to find y-intercepts, what do you plug in for all the x's? 0. If you're finding the x-intercepts, where do you look? The numerator or the denominator? Numerator. You're going to set the numerator equal to 0. And again, we're going to do this and we're going to do it again and again and again and again. So you guys, won't have the sheet in front of you, but you'll be able to, when I say, what are the x-intercepts? You're like, ooh, set the numerator. If I say, what's the vertical asymptotes? Ooh, denominator. And then we're going to talk about holes in a graph. That's where you're going to factor out the numerator and the denominator, and then anything that's in common, you cross it out. That's what Nick was talking about. And it doesn't create an asymptote, like a boundary line. It actually creates like a circle hole that is not filled in on the graph. Okay? All right.